In the previous lecture, we learned concave mirror, convex mirror, how they are formed, how a parallel rays passes through the focus actually, and it appears to come from focus. Uh, and we also learned uh, the relationship between the focal length from P to F and the radius of curvature from P to C, that is 2 times the focal length is equal to the radius of curvature, r is equal to 2f. Now now uh, now to locate the image of an object in a mirror, either a plane mirror or a convex mirror or a concave mirror, we can take any number of rays from the object and make it fall on the mirror and get them reflected to locate the image. But the minimum number of requirements is 2 rays. By taking 2 rays only, we can find the position of the image. Now the question is, which rays are convenient to draw? This side is for concave mirrors and this side is for convex mirror. Now the first one, a ray parallel to the principal axis after reflection from here passes through the focus, the first convenient ray. I have not drawn the normal here. The normal should have been this, where this angle is equal to this angle. And in case of a convex mirror, a ray parallel to the principal axis after reflection from here goes like this. It appears to come from a point called the focus. I have not drawn the normal here. It should have been like this. This angle is equal to this angle. Now the second convenient ray for a concave one, principal axis, the second convenient ray. Now passing through the focus, it becomes parallel. That is just opposite of that. Coming parallel passes through focus. So if it passes through focus, it will become parallel. Passes through focus, it becomes parallel. Here also I have not drawn the normal. The normal should have been like this. Similarly here, a ray coming in the direction of the focus, it will not, is reflected from here. So here the normal should have been this. So this is the angle of incidence, this is the angle of reflection, it goes parallel, the second convenient ray. Now the third one, the third convenient ray is a ray passing through C is reflected in the same direction, because this is the incident ray and this is also the normal. So the angle of incidence here is 0. Look, this is the normal. Suppose this is the incident ray. So this is the angle of incidence. If this is not the incident ray, this is the incident ray, then this is the angle of incidence. If this is not the incident ray, this is the incident ray, this is the angle of incidence. So as the incident ray coincides with the normal, as in this case, the incident ray and the normal, they coincide. So here angle of incidence is 0, therefore r is equal to 0. So it is reflected along the same path, means a ray passing through the center of curvature retraces the path. Similarly here, a ray coming in the direction of C, this is the incident ray, here this is the normal, so angle between them is 0, so it is reflected along the same path, right? Now coming back, so these are the 3 convenient rays. Out of these 3, you can take any 2 to locate the image. Now image in concave mirror, there are different cases, 6 different cases. Case 1, the concave mirror, the pole, the focus, when the object is at infinite distance, very far off, so the rays will be parallel. And if you are holding the mirror, this is the principal axis, such that the principal axis is parallel to the incoming rays. As you have seen in the previous page, pass through focus. So the image is at focus. The image is at focus. It is a point image. Case 2, when the object is beyond the center of curvature. Here is a concave mirror, pole, focus, center of curvature. Here is an object. This can be a candle or a pencil or a pen. From here, a traveling parallel passes through focus. I have told you before, to find the image, we need at least 2 rays. So from this point, this is one ray which passes through focus. The second ray passing through focus becomes parallel. The second ray passing through focus becomes parallel. So from this point, I have taken 2 rays, both after reflection, they meet here. Therefore, this point A dash is the image of A. So I drop a perpendicular like this. So your A dash B dash is the image of AB. Means if you put a screen here, you will actually find the image of AB. Actually find here the image of AB. It is inverted, small in size, actually formed real. So it is real, inverted, small in size, and between F and C. Small in size is same thing as saying it is diminished. Now the third case, when the object is at C, this is the object, ray parallel passes through focus, passing through focus becomes parallel. It is found, it is also formed at C, and if you measure the size, this size is equal to this size, actually formed, so it is at C, it is real, it is inverted and the same size. Now how to draw this diagram? While drawing this diagram, you might face some difficulty. So the best way to draw is like this. Draw like this. Draw a horizontal line. And draw a line here like this. Draw a horizontal line. Draw a horizontal line. The midpoint of this join with this. The midpoint from here to here join with this. So that is convenient to draw. Then the fourth case, when the object is between C and F, that is, this is opposite to the case 2. How? This is object, this is image. If this is object, this will be image. So this is just the opposite case of this. Now AB is the object, ray parallel passes through focus, passing through focus becomes parallel. So A dash B dash is the image of AB. Here it is actually formed, so it is real. If you can find, it is bigger than the object, so it is big in size, that is magnified, inverted, and beyond C is behind C. Now the fifth case, when the object is at F, this case is just opposite to the first one. Object at F, AB. AB is the object, this point is also the focus, ray parallel, going parallel to the principal axis, passes through focus. A ray from here going in the direction of C is reflected back in the same direction. These 2 rays become parallel, so they appear to come from infinity. So the image is at the infinity. Now then the last case, the sixth case, when the object is between focus and the pole of the mirror. This is a concave mirror, pole, focus. AB is the object between P and F. So to find the image of the point A, I have to consider 2 rays. Ray going parallel, after reflection from here, it passes through the focus as discussed in the previous papers. A ray going in the direction of C, here, it is incident here, and the normal here is normal, this is also the normal. So the angle of incidence here is equal to I is equal to 0. So it is reflected back in the same direction, and these 2 rays on this side, they diverge, means they will not meet on this side. So if you produce them backwards, they appear to come from a point A dash. Since I had taken 2 rays from here, point A, there, and they appear to come from here, therefore A dash is the image of A. Now I drop a perpendicular because it was symmetrical. So A dash B dash is the image of AB. It is behind the mirror. If you put a screen here, this will not be captured on the screen. Therefore, this is called a virtual image. So it is not real. It is a virtual one, big in size, that is magnified, and erect, and it is behind the mirror.